Welcome to the Weekly Squeak, your weekly geeky squeak with me, Christian Chiller. Sorry for the no-show last week. It was F Berlin. It was an extremely busy week here for me. I was helping organize some events. There was lots of people to meet, etc., and I just did not quite get the time to record a show. And it's also still in August, so still a bit quiet on tech news front. I think September is about to start to ramp up in busyness, and I'm going to be hitting the road again as well. So there's going to be plenty to report on very soon. So in this show, I'm just going to go through a quick few links that caught my eye over the past couple of weeks. And then I have an interview with Guo of Cypherium, where we discuss, yes, it's another blockchain project. I seem to be getting quite a lot of them at the moment, where we discuss consensus algorithms and their approach, their combined approach to them. It's quite an interesting interview, even if you're not into blockchain. Consensus algorithms are not new, and it's an interesting interview where we discuss what consensus algorithms are. So it might still interest you if you're building that kind of thing in other distributed systems. But in the meantime, let's get straight to the links. First, an article from The Verge by A.D. Robertson called Split Screen. This is the story of the Dragonfly Future. Well, actually, now there's an umlaut over the O. So Dragonfly Future Phone is an overpronounced way of saying it, but it's probably just Future Phone, I think is what it's supposed to be. This was an Indiegogo campaign from 2014 that promised a lot. It was palm-sized. It had a touchscreen. It had a fold-out keyboard. It had a second screen. You could run Windows and Android and do all sorts of amazing things. And if you look at the pictures, which were only ever mock-ups, it looks a little ugly, but this was 5 years ago. But it looks quite impressive, quite flexible. And interestingly, now we're starting to see real devices like this emerge. Not wanting to spoil the story that is coming, but you could probably see it coming from a mile off anyway. But even with companies like Samsung, their foldable phones have not gone quite according to plan. So foldable phones and phones that can double up as desktop devices are quite difficult, but they are coming slowly. Not only that, this device was going to replace your phone, your computer, and your tablet for $800, which even by 2014 money was not a lot, and all a bit too good to be true, and so it was. This has culminated now in an FBI case against the creator of the project. And not for just this. Actually, he's responsible for quite a few scams. So this was just one of several. But it's also an interesting story of how these earlier days of crowdfunding were not really equipped to handle such scams. I mostly am a Kickstarter backer. I've only ever had one project that wasn't delivered, and actually they're reasonably open about it. And it looks like there's kind of a relaunch of the campaign where they intend to also fulfill the backers from the first campaign, which I find somewhat impossible, but it's only a board game. It's not as much as $800. And it's only one, actually, I've had as a fail. So, but Kickstarter is a little different from Indiegogo. But this is an interesting story, another story of computing history. This seems to be a recurring thread, and it's not just because I'm trying to promote my podcast, Enthusiastic Amateur, with Sinclair Target, where we talk about computing history. It is actually pure coincidence. I suppose these stories just interest me. I also used to work on a board game that is on hiatus right now around computing history. But there's some wonderful screenshots and other stories of, this constant desire for sort of dual computing, split screen computing, a mobile device that can be turned into a desktop. And history is littered with failed examples of this. And Samsung DeX is just one of many. And we're yet to see if that is successful. Ubuntu phone tried to do this, and Ubuntu has an operating system that could at the time do both. Windows, Microsoft tried to do this, and it didn't really work either. So will it work this time with Samsung DeX? I think that is the more interesting side of this story. Is it something people even want? I think I would, if it was high powered enough, and some mobile phones now are, but let's wait and see what happens. But in the meantime, go and read the littered graveyard history of devices that tried the same in the past and failed. And now an article from Danny Guo. I'm not entirely sure how to pronounce the surname. From the LogRocket blog, The History and Legacy of jQuery. It's actually quite a short post, but I think jQuery gets a bad rap in this modern day. jQuery was one of the kind of groundbreaking JavaScript frameworks that enabled you to do much more with JavaScript. And now it's weighty, it's over-architected, a lot of times you can do what you need to do now with vanilla JavaScript, but let's not forget that it was there first. It filled those gaps for a long time. It's still very widely used thanks to being embedded in many content management systems like WordPress and Drupal and Joomla. And actually the argument I always had for it was that it was quite simple to use. Sometimes the best language isn't always the language that is best in terms of architecture and speed and things like that. But actually the language that's easiest for people to use, it gets people into programming, into development in the first place. And also jQuery kind of kickstarted things like the JS Foundation, the JavaScript Foundation, foundations for software. So its legacy is quite an interesting one and people should look beyond the framework that is now a bit dated itself. I think the other thing that always annoys people with jQuery is when you go to Stack Overflow and you have people asking JavaScript questions and people always respond with jQuery answers, which is always a surefire way to annoy Stack Overflow users. Not that you need another one. And if you're interested, jQuery is still under active development, actually. It's still widely used, despite being the butt of many JavaScript community jokes. It's still out there. It's still being used. So, it's probably still just as popular as other frameworks that are way cooler. So just bear that in mind next time you decide to make it the punchline of one of your jokes. Next, a topic that has interested me before. I think we have covered sort of related to this on the podcast before, actually. But this is a specific article on Gizmodo from Whitney Kimball called What MySpace Lost. It's obviously happened, I think, in the past year when there was a server migration from a few years ago and MySpace finally admitted that they lost a lot of data. The immediate reactions were, oh, MySpace is still there. MySpace still has data. Oh my God, I've got an account on MySpace. Things varied. But the interesting thing here was, and I mean, in many ways, I was a victim in quote marks here, in that a lot of musicians and artists put a lot of their work up on MySpace in the early 2000s. The band I used to be in, we started by putting out things on MySpace. This was the way that you promoted yourself and promoted your shows in the early 2000s. It was the age of MySpace and Napster. So for bands like the one I was in, it was the only way. It was pre-Facebook, or I think Facebook came latterly, but was not really optimized for music, which was, I think, intentional. So MySpace held a lot of early demos. In fact, I think we did have a lot of our early demos, which I also lost through other botched upgrades of my own. So they are now gone from MySpace too. And I think some of my solo music was also up there. And then there's some wonderful, well, not wonderful, but some very sad anecdotes in this article about, songs and music from people who have died, from parents and their children, and et cetera, things that were lost forever. And it does beg this question that we have definitely posed on the podcast before on if we put everything in digital storage, and especially cloud storage, not owned by ourselves, what is going to happen in 100, 200, 300, 400, 500 years time when people are trying to find out about our society and A, it's not there, B, it's not readable, et cetera. There are sites like archive.org who are mentioned in this article in their efforts to back up some, but not possible for all. But even then, who knows if they will last forever? And it's very interesting. It's like a book is old-fashioned technology, but a book has not changed in terms of technology for centuries. And you can still, if you can understand the language, read books from hundreds of years ago. Will we be able to even read documents we have created, media we have created from 10 years ago? I would challenge you to go and dig through some of your archive drawers and see if you can. I remember finding some ClarisWorks documents that I'd made on, Mac OS, who knows, 7, 8, 9 years ago, and being pleasantly surprised that TextEdit on the Mac actually still opens them. But I am sure I could find other formats that I could not open anymore. So I suppose the lessons here are keep things in open formats, not proprietary formats. With media, this is a little harder, but possible. Keep offline backups, keep as many copies of it as you can. And hopefully we will have things for the future. We will have the crap we made as teenagers available for people in the future. But still, it's an interesting reminder of how much faith we put in sort of hosting services these days. And finally, another piece that I have certainly started following quite a lot recently from Atlas Obscura, from Genevieve Carlton, how to put a fake island on a map. This is the island of Friesland, just south of Iceland. But to be honest with you, in history and in historical maps, there are many examples of these sorts of things. Sometimes to prevent copying, so you could see if someone had copied your map. Sometimes because people just genuinely thought something was there. There's actually, I read recently in a book about the discovery of America, how some of the early explorers of America just made it up, what they thought bits of America would look like. And it was amazing how accurate some of them were. So things like Australia, no one envisaged, well, no European, I should say, envisaged was there until they fully mapped it. In the case of Friesland, it's mostly around reputation. He came from Venice. Venice was waning. They wanted to reclaim their grandeur by claiming they had discovered a new place, even if it was an island to the south of Iceland. And then the legend stuck. And it was actually still shown on some maps up until the beginning of the 20th century, which is quite amazing. I would wonder if anyone actually ever tried to visit. This would be a surefire way to prove it didn't exist, interestingly. But sometimes it's more that the stories behind these things are so compelling that I guess people just believe them. And Columbus, who, is renowned for discovering, in quote marks, I have to keep caveating that, definitely, although he didn't discover as much as some people think. He invented a lot of stories about how he got there too. This was how books were told. It's not too dissimilar from some of the media now, really. To be honest with you, it hasn't really changed. It's just that that's history and now this is present day. But I'm sure there will be similar stories we are telling in several hundred years' time about how some scientist or politician exaggerated the truth. So it's an interesting story of history, of fantasy, of fact, of believing fantasy and fact. This is actually starting to sound like a very contemporary story, isn't it? So a lesson from history to not always believe what you read and maybe sometimes try and prove it if you can. If you have a ship available to you to go and prove an island does not exist. I wonder what we now think is fact that in 100 years' time we will discover was a complete fabrication of someone's imagination or storytelling. That was my links for the week. And now here is my interview with Guo of Cypherium.
My name is Guo, and I'm the founder and CEO of Cypherium. We are working on a new public and enterprise-ready blockchain that supports thousands of transactions and a Java smart contract. Our blockchain is based on a hybrid consensus algorithm of proof of work and hot stuff. Hot stuff is a new Byzantine fault tolerance algorithm that was published last year. And it's also adopted by Facebook's Libra BFT.
What do you mean by enterprise ready? What makes a blockchain enterprise ready?
Enterprise ready means that this software platform must be able to support a large traffic of use cases, and also it has to be secure. That's like the two most important features about enterprise softwares. Plus, it also needs to support like a user management and other features more complicated than traditional consumer software. Most of the existing blockchain platforms can only process like around 10 or several hundred transactions at most. But for enterprise use cases like payments and other potential blockchain use cases, they often require at least several thousand transactions per second. And no public blockchain currently is able to do that yet.
And does this also mean that it's a private blockchain, I'm assuming?
It actually is not related with either private or public, because enterprise blockchain can also be public as well. But most of the public chains are inefficient and slow. But our blockchain is public too, and we are making it faster than the existing public chains.
Okay. And is that thanks to the consensus algorithm, or is it thanks to different reasons? Or like, How have you made it so much more efficient?
Because we use a hybrid consensus mechanism. We use proof of work to make our blockchain decentralized. That works kind of like a Bitcoin that uses proof of work, also known as mining, to elect a group of validator nodes. And these validator nodes then verifies the transactions using the Byzantine fault tolerance algorithm. And in our case, it is hot stuff. So it works kind of like a voting. If more than 2/3 majority consensus is reached, then the transaction is considered valid and instantly committed. There is no confirmation time because the Byzantine fault tolerance algorithm does not have the chance of a fork like a proof of work does, because it is instant finality compared to the proof of work, which has no finality but only probabilistic. And our validator node group is constantly changing because for any several minutes, a new miner joins the validator and the oldest miner leaves. So that makes it a dynamic group.
Oh, really? Actually, that is that unique to Cypherium? That sounds like quite an interesting idea, actually.
Actually, there are also several projects claiming to do the same, like Zelica, but we don't know like how complete their implementation is because its founder recently just left the company.
Oh, okay. I didn't interview them before, but yeah. Okay. And when you say the oldest mine, I mean, what can that mean? Are we talking minutes, weeks, months?
So the miner that signed the blocks most of the times, is what we consider oldest, and usually it's proportional to the time that it's joined in a committee of the validators.
And I mean, is it all based on private keys or something like that? Can a miner just come back again? Or
yes, a miner is identified by its IP address and its private key.
But can the same one come back again after a certain time period?
Yes.
Okay.
There's no censorship of miners unless it did something bad.
Yeah. Okay. And so hot stuff you mentioned as a consensus mechanism, and you also mentioned it was adopted by Facebook's Libra. What makes it different from proof of work?
The classic proof of work is usually called Nakamoto consensus by the academics. First, it's fully permissionless. Anyone that has a computing device can perform the proof of work and have the chance of joining the consensus. But the chance just varies according to one's computing power. So if you have like a ASIC machine, you have a much higher chance of finding a proof of work than if you are using a CPU. But the Nakamoto consensus does not have finality, and anyone that controls over 51% of computing power in the network always has the advantage and can eventually control the whole network, so that the Nakamoto consensus is always probabilistic. That means there's always a chance for the blockchain to fork. But the Byzantine fault tolerance algorithm, which hot stuff belongs to, is a class of what is called quorum-based algorithm. So it acts like a voting that a group of validator nodes votes on the authenticity of a message. And if the leader of that validator group fails, such as crashes or commits some bad behaviors, then other, what's it called, the backup nodes will initiate a process that works like an impeachment that kicks the leader node out and elects a new leader. So it works pretty much like a Congress or a parliament.
Yeah.
And traditionally, the classical Byzantine fault tolerance algorithm is used in internal systems like a private blockchain, as you mentioned. But recent research also opened up the chance for it being adopted by public blockchains. So, like us did, by combining proof of work and the hot stuff, we can make it both fast and decentralized.
And I guess that ties in quite well with the feature you have about removing older miners as well. You've almost got this kind of political system going on that mimics the real world of cycling politicians as sort of relatively quickly. In certain countries, of course. So, yeah, it's kind of interesting that it basically mimics a real world system, but in a digital way, I guess. Yeah.
Yeah.
And you've taken a very much of an enterprise approach here. The smart contracts run on Java, or they are written in Java? That's something I was just trying to understand.
First, our blockchain has a JVM, and unlike most blockchains that uses the EVM, the instruction sets in our blockchains are compatible with the Java standard. And also, our smart contract can be written in Java or any other language that you can do with the JVM. So our official smart contract language is Java, but you can write smart contracts in any language that you want, as long as you can translate your code into the Java bytecode.
Okay. Just out of interest there, though, one of the common arguments against Java is the JVM makes it a little slow. So is that a concern, or have you managed to tweak that somehow to make it not as bad or not as bad as other virtual machines, I suppose?
According to our test, we found JVM is actually faster than the EVM. Also,
for sure.
Yeah,
for sure.
It saves the space than the EVM bytecode, because the JVM has been there for many years, and it has a lot of optimizations, and also it has a much more stronger community and a standard library. So if you get started with the Java programming, it's much more convenient because you have like everything ready in front of you, rather than the EVM and Solidity that you have to code a lot of things from scratch.
Yeah. And sorry, just to go back a step to the consensus mechanisms.
Sure.
How does the proof of work and hot stuff interact with each other?
So the proof of work we use serves as a identifier and also as a mechanism to prevent what is called Sybil attack, because we have to set up some bars to prevent malicious nodes to join our network. And if a hacker that controls like hundreds or even thousands of botnets, it will severely harm our network's integrity. So that we use the proof of work. You have to make a computation and spend electricity. There's a cost associated with the electricity. And in order to join the committee, you first have to pay that cost. Otherwise, you are not allowed to join. And because there is a check and a balance among the validator nodes, if you commit some bad things, you will lose your block rewards and get kicked out by the validator committee. So the hackers won't be motivated to do that. So that's our security mechanism.
Okay. And continuing down the enterprise readiness path, you've also got partnerships with IBM and AWS, two companies that enterprise would be very kind of familiar with. So are IBM and AWS actually offering Cypherium on their blockchain as a service platforms, or is it a different sort of partnership?
Yeah, that's what we are doing with AWS.
Okay. And is the IBM partnership anything to do with Hyperledger, or is it separate from that?
It's with our own blockchain. So IBM is also exploring other blockchain infrastructures in addition to their Hyperledger platform, and currently they are considering Cypherium.
Okay, interesting. And let's come back out of the technology for a little bit. How did you get here? Why did the team decide to start on Cypherium? What difficulty, what problems were you having with existing options that you wanted to solve?
So I came up with the idea of Cypherium in 2016. That was 3 years ago when I first met Ethereum. And I found that Ethereum was slow because for a transaction to be considered permanent, it takes several minutes, and it only can process 12 transactions per second. That's super inefficient. And you have to pay a lot of gas fees. That also makes rating smart contract costly. So I think that Ethereum is not ready for practical and real use cases due to its limitations. And then I decided to create a better blockchain. But because the existing algorithms all had their own limitations, proof of work is decentralized but super slow. The PBFT, also called practical Byzantine fault tolerance, is fast, but it's centralized. So the way to make a both decentralized and fast blockchain is to combine different consensus mechanisms and make a hybrid consensus. And by that time, there were already some papers discussing the possibilities, but they are all research prototypes. They are not actual working products. So I decided to build a blockchain that's functioning and based on these research works. So I first reached out to some professors that developed the idea, like Emin Gensayer, the Cornell professor, and Brian Ford. And he works for EPFL in Switzerland. And after I got support from them, I started to build the team. So I brought in my friend and their friends, and we began a team of about 10 people in the beginning. And we started building our project and writing our code. And later we learned about hot stuff. That was from my friend who's a PhD at Cornell, and he's the first author of hot stuff. and he recommended me because it's very simple to implement, and also it reduces the communication complexity of the traditional Byzantine fault tolerance algorithm. So that's why we decided to adopt hot stuff algorithm. And it's coincidence that Facebook later also began using hot stuff.
What's the plan for kind of rollout? I see you have a mainnet announcement. Do you offer a mainnet yet, or it's yet to come?
So right now our mainnet is in the beta stage, and it's available to download at our GitHub, and it has all the functionality that our mainnet has. So it's differently from like a private testnet, because most projects claim that they have a testnet already, but that's not publicly accessible, and you don't know how good they are. And our mainnet now, it's ready. Just there are some like bugs we need to fix before we release the mainnet, and we are definitely close to our mainnet launch.
And are there any projects running on the testnet at the moment that have been helping you kind of prove the validity of your...
We have some developers who already created several smart contracts and test transactions on our test mainnet.
Okay. And is that possible for anyone to see those, or is the testnet relatively private?
So we have a blockchain explorer, and you can go there to access. And also you could download our client and run some transactions and smart contracts yourself.
Where do you find those? Are they on the GitHub? They don't seem to be on the website.
Yes, our GitHub.
They're in GitHub. Okay. Yeah, I think I can see some things here. Okay.
Yeah, check it out.
Yeah. And apart from the mainnet launch, what's kind of next on the roadmap?
We are all currently working with some other partners to get more exposure and potential customers. And also we are filing patent for our consensus algorithms. And that's like our current plan.
Oh, so okay, just to go into that. So when you say you're combining two existing consensus algorithms, you're not combining them in their kind of purest form. You've created your own based on the bits of them.
That's correct.
Is there anything that you want to make sure is mentioned that we haven't mentioned?
I think pretty much everything has been mentioned.
Yeah, you gave very short, very concise answers.
Yeah. And I enjoyed answering those questions from you too.
I think we got everything. I think I got everything I need.
Yeah. Pleasure to talk with you.
I've actually been chatting a bit with some Java Ethereum developers. I might have to send them the project to see what they think.
That's awesome. So if you go check out our GitHub, you could find some smart contract examples that are written in Java. And also we have a video on YouTube that demonstrate how to run both Java and Solidity smart contract on Cypherium.
Ah, okay. So you said JavaScript as well? No, Solidity, sorry.
Solidity, yes.
Okay. Yeah. Okay. And so you can also compile Solidity to work on Cypherium?
That's right.
And is that going through some kind of... Well, I mean, Solidity compiles to bytecode, so I suppose you could compile it to bytecode and get it to run on the JVM somehow, I guess.
So we have an EVM also. So that we have two types of VM, JVM and EVM. But the next step, as you mentioned, we might implement a translator for Solidity so that you can compile the Solidity code directly into our JVM bytecode.
Yeah.
But now, that's the next step. Our current focus is on the consensus mechanism and the mainnet.
Yeah. Okay. Cool. That's actually quite interesting. Yeah, that's an interesting idea. And I think I know Solidity offers a lot of kind of options for getting Solidity code out of Solidity into something else. So it helps projects like you actually. And because smart contracts are actually never that complicated, really.
Yeah.
It's not too hard to translate them. Yeah.
Yeah.
And you already have like Java wrapper classes in Web3j and things like that. So yeah. Okay. Cool. Interesting. And I'll definitely send this to the Java devs I've been working with recently. They might find it interesting, or they might say,
That's awesome.
I don't know. We'll see. And that was my interview with Sky Guo of Cypherium. I hope you enjoyed our discussion. That is another Weekly Squeak for this week. I think September will get much more active again. Lining up quite a few interviews from Berlin Blockchain Week. Yes, some more blockchain. Hopefully some other subjects for the rest of you as well coming soon. If you have enjoyed the show, you can find previous episodes at christianschiller.com/podcast and the accompanying newsletter at /newsletters. I'm hitting the road for quite a few events over the next few months in Osaka, in Belgrade, in Prague, in other places that names escape me right now. Go to /events on christianschiller.com to find out more. And I'd love to meet you. Let me know. I'd love to meet you in person if you're a fan of the show. If you are a fan of the show, please rate, review, share wherever you listen to the episode. Listeners are creeping up. The past couple of episodes, the listener numbers have been slowly increasing. Good to hear. I'd love to hear from any of you who are new. You can also find ways to get in touch with the show at /contact on the same website, or on facebook.com/christianschiller, or at chrischinch on Twitter. So until next time, thank you very much for listening.